last log we will describe here is the caliper log. It is used to physically measure the diameter of the borehole from bottom to top. The hole diameter can give an indication of the type of rocks present, a general indication of permeability, plus it gives the drilling department an indication of potential hole problems. When using this tool, several spring-loaded arms on the caliper are lowered to the bottom of the borehole. As the sonde is raised, it measures the hole diameter. Knowing the size of the hole is critical. A hole that is on gauge, or equal to the bit size, can help locate non-permeable formations. For example, a hole that is larger in diameter than the bit can indicate weak or unconsolidated formations. Conversely, holes that are smaller than the bit can indicate swelling shales or large mudcake development, which indicates porous permeable zones. Each of these indications can impact the drilling program and need to be factored into that program. In addition, the results from the caliper log can help in calculating the hole volume, which will become necessary when determining the quantity of cement needed for casing. It is also good for locating good packer seats for the DST. Let's review the logging tools, the sondes. The spontaneous potential, SP, and the gamma ray, GR, logs help us establish lithology and the formation boundaries and thickness. The density, neutron, and sonic logs help determine the porosity of those formations. The resistivity log helps determine the fluid type. The caliper log, which gives us a shape and diameter over the entire length of the hole, allows us to calculate the volume of the hole, which will be important when we begin the casing run. The caliper log also allows us to identify the type and location of the reservoir rock. Finally, knowing what the hole diameter should be and what it actually is gives us notification of possible areas of concern over the length of the borehole. Finally, the last test, the initial potential IP test, is conducted after the well has been completed and equipped in what is known as cased hole or closed hole, but before the well has been prepared for production. This very important test allows reservoir fluid volume or flow rates and pressure measurements to be accurately determined. The initial potential test, IP, determines the initial productivity and is done over a period of from 24 to 36 hours to calculate the numbers of barrels of oil, of salt water, and the volume of gas that can be produced during this 24 to 36 hour period. The report of the IP test is evaluated very carefully because it is often the first dependable indication of a well's productivity. Because this test is done only after the well has been cased and after all of its load or mud fluids have been removed, we mention it at this time only because it completes the series of 3 tests: the DST, the WFT, and the IP. A more detailed description of how this test is performed will be presented in Chapter 8. In Chapter 7, we have discussed the methods used to extract data from that borehole and described how we measured the borehole area with the mud logs and various sondes in the logging suite, how we captured rock types, the cores, and how we tested pressure and fluid samples with the drill stem test, the wireline formation test, and the initial potential test. We've shown how we were able to use these measurements, samples, and test evaluations at different stages and depths of the drilling program to help us identify any reservoir rock that was present. Once identified, we added this information to the mud log as we drilled and then compiled another, more detailed electronic log after total depth, TD, was achieved. Along the way, we continued collecting samples and performing tests that helped us determine lithology, porosity, permeability, and saturation, or types of fluid present in that rock. Next, we determined the depths, size, thickness, temperature, and pressure of the rock formation. Finally, by using the data from all of these procedures that help us evaluate the formation rock and from the results of the seismic tests conducted earlier that gave us the area, we were able to calculate if there was enough commercial quantities of hydrocarbons present to continue the development of the well. Tests described in Chapter 7 gave us valuable information about what is in our borehole. If the well is considered dry, meaning no commercial value of hydrocarbons, we will plug and abandon that well. On the other hand, if the tests were positive, we will move to the next phase called well completion. Chapter 8 will describe in detail well completion.